So, hello everyone to our webinar, Introduction to UMH Core. Today I'm hosting with my co-host Alex. My name is Matthias, and at first we're going to start with a quick introduction to ourselves, then also UMH for anyone who's joining newly to our webinar series, and then going to jump into the challenges that we identified while working with our customers in the last year. Then pretty much how UMH Core addresses these challenges, how it's built up, and very specific features that we additionally added to it, the data modeling. Just as a sneak peek, not as a full-blown webinar yet, which is going to come probably in the next 1 to 2 months, let's say. Great. Okay, cool. So would you like to start?
Sure. Thanks, Matthias, for preparing this webinar. I'm Alex. I'm the co-founder and CEO. Actually, mechanical engineering background, and first sidetracked into system integration for 2.5 years. And after that, 4.5, 5 years back, I founded together with Jeremy UMH. And so happy to share a little bit about what we learned across the years and which now led to the creation of UMH Core. And can't wait.
Thank you. So my name is Matthias. I'm accounting executive at UMH, also mechanical engineer by background, but then spent 5 years in management consulting, doing digital transformation. And now I'm supporting our customers in pilot and scaling. So whenever you have questions about success stories, typical integrations, use cases, and so on, feel free to reach out. Cool. Then let's give people a quick intro about UMH, what we're doing, who we are. So in general, I think most of you are well aware that we're talking mainly about the unified namespace in combination with UMH. So on the left-hand side, you see pretty much where we're all coming from, why we are talking about unified namespace, the typical spaghetti diagram of industrial standard when it comes to integrations, and where we're moving and headed as more and more the single source of truth, the unified namespace, where you only do every single integration once, standardize, model the data, and democratize the access to it to really make data a commodity on the shop floor instead of a business case. So for this, UMH includes many features. I think the 3 most valuable are the connectivity piece. So tons of interfaces that are supported from IT, but also OT. Then the data modeling, which includes data standardization, data governance of specific data models and so on, which we're going to touch a little bit in the end of the session. And then, of course, the historian and the use cases that we built on top. Just because talking about infrastructures, unfortunately, a lot of times not so sexy, but the business case behind the use cases. So this is why we also try to cover this end-to-end story when it comes to integrations in unified namespace. So pretty much from connectivity to business value. So for this, UMH includes a couple of elements. We integrate always parallel to the automation pyramid, so no rip and replace methodology, but really just adding continuously integrations with a business value, collecting data, and so on. And besides connectivity, data out, message broker, historian, and visualization for the use cases. Pretty much includes all of this in a single installation command. So it's a single platform, single infrastructure. So you have everything from the get-go without doing all the integrations by yourself. And with this, we then pretty much define the unified namespace. Here on the right-hand side, you see a little bit of an example of the classic ISO 95 hierarchy that you can build up, starting with enterprise, site, production areas, production line, machines, and so on, down to the sensor level. Standardizing, modeling the data on the way there. So at the end, it's very easily reachable in the database or within Kafka for real-time data. And then this is pretty much the groundwork that we do to build up the use cases, which can span from simple condition monitoring, KPI tracking, alerting, up to really more complex MES applications if you really want to go into the nitty-gritty of system integration. That's and now pretty much it to UMH itself, And so let's then talk a little bit about the challenges that we had last year, pretty much. Also before that, but pretty much where did we go? Where did we start all that?
So fundamentally, I think there are 2 things where the UMH Classic left a gap. In the market, there was fundamentally the way how you could deploy software, and then there was this, let's do it in Kubernetes. You can also do it as a binary, so install it on Windows, or you can do it just in a simple Docker environment. And then we chose back then the route because UMH was multiple services. So Kafka, MQTT, database, Grafana, and Bentos, etc. Like the logical route for us was getting into a K3S, which is a minimal version of Kubernetes type of deployment, which on the upside, you can directly make it as a high availability setup. It imposes the ability to be quite scalable. So not only like from the availability perspective, but then also under increased load, you can scale services as they now need. And yeah, then you have this integrated features of versioning, which now is a standard feature in Kubernetes with Helm chart, etc., etc. The problem that we saw are two things. I think the first and most awkward one, specifically as an open source startup, it makes it harder to get started. Yeah, so you have like a little bit of prerequisites that you need to cater to. For example, you need to have a certain operating system, which we then enable to then install Kubernetes into. Then you need to install UMH into the Kubernetes cluster, which is actually a multiple step approach, actually closer to installing software as a binary, not as a to be installed software stack like in Windows, which has a lot of requirements on their side, which was quite a problem. And secondly, it also is like a little bit unflexible. If you want to have like super specific Kubernetes requirements, if you have your own OpenShift or your own Kubernetes distribution where you want to integrate it to, which then need a little bit of configuration. Not impossible, but fundamentally on both sides, not that easy to do. So then on the other side, you could just have it in a single Docker container. So like one product, one thing, one Docker container. So it's super easy to get started, completely independent of the operating system underlying it. It's super low complex. So Docker run up, done. The problem that normally comes with it, it's not separated. This was also one of the key design decisions that we took when choosing for Kubernetes. If one service fails or one container fails, it doesn't take down the rest. And this is what we see in huge problem with a lot of existing tools out there. For example, take one node RED and you connect multiple machines to it. One subflow is like creating critical issues. Could be various reasons for that, but it's also not node RED. It could be all types of software. But then it takes the rest of the stack with it. So misconfiguring one machine PLC now causes all the others to actually drown. And this is something that we said, okay, UMH Core needs to combine a little bit of that. So we said, fundamentally, we want to have this easy to deploy container, which is then just one single Docker run away from installing the UMH Core components, which in our case is Bentos and Kafka, are getting data in, modeled out. But under the hood, we rely on a process management software, which is called S6. It's actually a little bit old and boring, but fundamentally it segregates specific processes. So what your PC would do in the backend, like you have a Skype, etc., as decoupled processes. So if one dies, it doesn't necessarily take the other with them. And this is now the same logic that we applied also to UMH Core. So Kafka is its own service, and then each additional Bentos configuration, which shoots data from A to B, is all an own service. So it's completely decoupled and thereby actually more scalable in a lot of ways, because before we relied on a pod per UMH Bentos. So each new connection spawned a new Docker container. There's a pod limit of roughly 100-150 containers per Kubernetes cluster, which is now not a limitation anymore. You can run thousands of processes. And so under the hood, UMH Core is actually more scalable than UMH Classic. It doesn't have all the components in there. So UMH Classic is definitely a piece of software that we will support looking forward. But at a certain point, we'll now merge both user journeys to replace certain components in the UMH Classic Helm chart with UMH Core. So fundamentally, this is but also the good thing, UMH Classic is a Helm chart, so we can, across versions, interchange components, and this will definitely not be something that we neglect, but fundamentally make it easier to get started, and also then to integrate. If you have super specific Kubernetes requirements, you can easily install it. You can configure it via CI/CD because it's fully compatible via external configuration files via YAML. So I would say best of both worlds, but we will show you.
Yeah, I think so too. Also to give you a little bit of perspective, from our experience, what could go wrong? Just working with K3S a lot of times, just due to random changes in the kernel of the Linux OS could result in pretty much a lot of unnecessary friction in this installation process. This is one thing.
For example, this IP addressing. Yeah. So
yeah,
like it sounds counterintuitive, but changing an IP address of a VM should not be a thing. But if you run Kubernetes on top of it, it will actually tank the whole system. And this is
the same with the host name. Yeah, so this can be definitely a huge issue. So just like some little complications within operating it,
which are fine by design, but you need to be very careful of using that, which
makes it a little bit difficult for a starter. Yeah?
Exactly.
I think this is pretty much the case. So our wholehearted spirit in that is pretty much like make it as easy as possible for a starter to get started. Yeah, while at the same time still saving all of these K3S capabilities as much as possible within this concept. So you have really like an easy start and quick ramp up to an enterprise deployment here. Yeah, so this is pretty much why we are going the way we're going and what it's all about. Let me show you a bit of an architecture page just to simplify it a little bit more. So I think a lot of you already know a similar page that we had in the past with UMH Classic. UMH Core, as it is a single container set, it's pretty much including UMH Bentos. So we're talking about all of the integrations, protocol converters, like custom data flows that you want to set up, any stream processing capabilities that you want in there, and additionally Kafka. Yeah? So Kafka is really now the heart piece of UMH Core. So we are bringing everything to Kafka, storing, forwarding it there, are able to have like a 1 week retention time and more. Also post-mortem, do all of the stream processing and so on if you want to have like quick development cycles. And additionally to that, if you require it, of course, still include timescale, Grafana for the historian features and use cases. And if MQTT is more like a required interface for you because some PLCs, some MES system as they are out there and so on, then we would also deploy this as an additional container. Yeah. So
which is one really interesting piece. It's also like the UMH cores that you see at the bottom. We often see, specifically in, I would say, higher secure networks, that you have segments which you need to cross. Yeah, so you have specific parts of the production even encapsulated in an additional network, which now needs like an additional piece of software to push the data out. Yeah, because you cannot come top down from the network perspective. You need to push it out, which we would back then mostly do either via UMH Classic deployment on an edge device, but it needed to be actually a little bit more powerful, so 4 core 16 gigabytes, or used Bentos as a single container to push the data out. But then you don't have this fault tolerance, you don't have the buffering, etc. And now with UMH Core, you can take this perhaps a little bit dated device that you already have there. So there are often a lot of OT firewall providers which actually have the ability to now deploy software on top of it. So either in Docker or Portena or whatever. And now this makes it actually even more compatible from reducing the system requirements and also the operating system requirements to integrate with whatever you have down there. Could be Raspberry Pi, could be, or like in Revolution Pi, so more industrial standard, or like an IT OT firewall, yeah?
Yeah, so like any modern PLC would be also able, or like industrial PC would be able to run it.
And there are some PLCs, modern ones, actually able to run containerized environments.
Luckily nowadays this is possible, which also then implies that you could, for example, set up this specific environment for a production line for a machine and so on with UMH Core, do all the integration, standardization and so on, and then just packet everything and then just ship it to the actual site where you want to have it, and then really have a machine including integrations and use cases like off the shelf, out of the box. Yeah. So like, playing with ideas like that is not possible compared to before that. Because now we're talking about like 2 CPU cores, 4 gigabytes of RAM that are required to even have a bit of headroom for multiple integrations. Yeah. So it's I'm gonna easily show you how it's running on my laptop over here. So yeah, this makes it way easier.
Yeah. Perhaps there was one question from Luciano about the plugins and the availability date of them. So the plugins are currently actually like an intermediate step from migrating from UMH Classic to UMH Core. So this is only currently available for enterprise customers, where we then currently migrate them to a UMH Core architecture. We do that. And then over the course of that, we will then also push that down to the community version of the UMH. But it will take a little bit of time. This will then also be a fully open source offering from us. So don't worry, you will get it. But currently it's still only available for enterprise customers.
Okay, we have one more page of it talking about architecture itself. This one over here. So some of you might also know it. But in general, this is where you would deploy UMH Core instances and separate segregated networks that you have, and then the full UMH instance, if historian and Grafana on-site level are required, and then once again push it to the cloud of your choice or to a central UMH instance where then you combine pretty much all of the unified namespaces together. Yep.
Yeah.
So
there was also one question that we get up front that I would like to take at this specific moment. There was this, are we supporting UMH Classic or are we dropping that? This was like a question that came up front. Definitely we will support it. UMH Core is an extension of UMH Classic to, for example, environments like that. And over the course of the next months, some core functionalities will also be available in Classic. So at some point, the architectures will meet again, and we will guarantees like make sure that all migration paths are available and automated. Yeah. So definitely we will not neglect UMH Classic. But it's currently like 2 products to extend the current offering, and they will again, from the architecture perspective, will migrate into each other over the next months. Yeah.
Okay. So how about we just show you what UMH Core is, how to install it, and how to run. So for that, as usual, we will go to the management console and add a new instance. So over here, you will see that we have under type, now Classic and Core. You can select Core, the specific release channel you're working with. I'm just gonna name this Enterprise. We are colon here. And this is gonna be our office. So, and yeah, this is pretty much how you want this exactly as before with the K3S deployment to UMH Classic. You receive now your single installation command. You can copy it.
And in this case, it's now a Docker run versus like a shell script, yeah?
Yep. So once again, you see all of the environment variables, the UNS that you defined, including the version tag.
And the API key, congrats, which you could now screen capture now.
Yeah, too late. And then over here, I'm just going to put this into my terminal, drop the password, and then we'll be installing UMH Core over here too.
We will now pull the image from our container registry. And there was also one more question that I would like to take from Luciano. What is the recommendation for new projects Core Classic? It depends, like every good answer to a question. So if you are currently requiring the plugins, so Grafana, Timescale, etc., pp. We currently still recommend starting with the UMH Classic because this is baked in and there's no yet the open source version available to that. If you currently just require to move data from A to B, so build a UNS with no database, for example, to push it directly to the cloud or integrate into certain applications, you can currently just do that with Core. Yeah. So full stack Classic, just moving data and building the UNS, Core. And then over the course of the next months, there will be the plugins available, which our recommendation will be then still Core with plugins equals Classic. But yeah, this is our recommendation.
Yeah. So as you see over here, UMH Core is now running. So as usual, as before, we have here specific instance details. So how much resources are we using, any error messages and so on. And then also, as you see over here, pretty much the current versions we're running. Yeah, so it's Red Panda, it's Bentos, it's S6 overlay. So
it's still not a monolithic software. Yeah. So it's again like not containers inside, but services inside to decouple them. And this is just a transparent communication on that.
Yeah. So I think Config I'm going to show you later, just to know overdo it at the moment. And then, as usual, we can over here and pretty much connect also to our devices over here. So you see there's a single bridge, so S7 over here, and the configuration is a little similar as before. Yeah? So here we have over here the node IDs that we can include. Then any potential like data processing, if based on the node IDs you want to calculate, recalculate specific parameters. This could be, for example, moving from Fahrenheit to Celsius, but could also be like simple case statements and so on that you have over here.
Well, one thing I think everybody's questioning now why it's still already there. I think when you installed it, you didn't remove the old volume from the container.
Yeah, so don't wonder about that one.
But interesting, you just installed it, the configuration was there and it was already spawning that, which I was also like, why everybody, there was also something flashing here. So the So it's still completely available with all the logs that you would know and love from the UMH Classic. So even in this containerized environment, we provide multiple levels of logs for each individual bridge, for the agent running inside, etc. So no features lost on that level.
Exactly. That's the same with metrics and so on. If you're interested, how many messages are pushing, how many are successfully processed.
Which is also available via Prometheus now. Yeah. So
this interface. So if you have any error logs that you would like to capture, set up an alert based on that, which could be super relevant if you have pretty much any data source that you want to track and ensure that it's like as high availability as possible. And if something goes down, then you want to be notified, or IT wants to be notified immediately. Yeah, because we know a lot of times, some DNS IP changes and so on can lead to pretty much data downtime. So this integration to Prometheus and by that into Grafana, alerting and so on is also natively included.
So easier to get started, also with logging and tracing. Yeah,
exactly. So as usual, we have our topic browser over here. This is pretty much what I integrated over here. So I have a string that's coming in, I have temperature, and a machine RPM as before. Yeah, including over here, you see tons of metadata that we included this time in the topic browser itself. So this is pretty much where you can use specific node classes, node IDs, anything else to pretty much build up your logic, how to process data, how to structure it, and so on.
Which is actually also quite powerful. So you see, it's not only like the bridge is not only extracting like the pure data, but you can also see what additional meta information, either on the specific PLC, on the connection itself, or whatever might be exposed via OPC-UA. So we don't like just extract the value, but we really make sure that the whole tag with all the information already provided is getting into your UNS and will be available via meta. And then you can do whatever you would like it. You can add it to the payload to shoot it somewhere. You can just leave it as it is for troubleshooting later on. Yeah, but we don't strip away any of that goodness.
Yeah. So pretty much this is as before it was the very clear, simple start. Yeah, you install UMH within a couple of minutes. You build up your first bridge, first connection. You define where node IDs are supposed to be saved and have like a simple UNS over here. Yeah? Then the next step, we are also introducing data modeling. Yeah? So to data modeling itself. Under data model, we understand pretty much a template which has to be filled with specific data types, specific constraints, and this you want to enforce within your organization. So let's talk about simple example. Over here, for example, you have a specific standard for an oven, for instance, CNC, maybe for a fryer or something like this. Yeah, you want to say, hey, I have exactly these are my data points. It's going to be temperature, RPM of the machine. It's going to be the machine states in a specific format. If I get the temperature, it's not allowed to be like below 0 and above 100. Otherwise, I know already the temperature is wrong. Yeah, stuff like this is pretty much what's going to be included in the data model. Yeah, so let's take a quick look over here. There we go. So there's now a simple version 2 that we have over here. On the right hand side, some nice examples of how you can build it up. Yeah. So over here you see temperature as one of the tags that we want to have over here. It's supposed to be time series data. Additionally, later on, there you go. You're also able to include constraints and also metadata. So for example, you have the engineering comment that you would like to add because this is a specific sensor, specific machine, OEM, whatever. And additionally, set the constraints. So
temperature should not be below 273 degrees.
Exactly. Yeah. So at the moment, it's pretty much about the data type. So if it's a string, it's a time series. You will see that in the difference, or like no bad data in that case is then moved to the UNS. And
it's also now on top. So why are we doing it? On the first glance, it looks like an unnecessary step that you now have these models because you can directly in the bridge theoretically make everything neat and tidy. You can add the metadata there, you can format the topic already in there and model the payload with the functions that are available. What we saw is even then, and specifically while collaborating, data models can drift. And then you have like still the situation that on the application level where you want to expect a certain payload, you expect a certain model of a CNC machine or of an oven where you now say, okay, I standardize my API based off these 3 data points that are always available, and then you start drifting in between, you will get problems. And this is the modeling function. It's more a governance layer on top that helps you keep it clean inside your UNS. Yeah? So you are able still to push it in and then model it, but you now can expect and you rely on certain tags and meta information which are available. You can expect that constraints are met. You can expect meta be there. So yeah, so it's something on top to make sure that your UNS scales with your organization and doesn't drift under multiple users over a certain period of time.
Yeah, especially when we're talking with customers that have like dozens of sites or 100 plus. Yeah, just having a very clear data model governance is incredibly crucial. Otherwise, if you push the data to the cloud and have it all centrally in the UNS and so on, you are still not able to compare the data. Yeah. So, for example, one use case we were discussing is I want to have the data in the cloud, and then based on the product order, I have to schedule for a specific site. I want to understand, hey, where would this product order actually run the best, globally speaking? Yeah, and also additionally under which process parameters. So having this then 20 production lines that have exactly the same data points, same data model, and so on. Suddenly you have the capability to actually do this analysis and understand where do you want to position your orders, schedule production, and so on. Yeah, so it's a bit of a long tail of a use case, I think, and a bit of a North Star for a lot of companies. But just slowly building up to that is like the requirement to actually even think about such a use case.
I think what's actually like an even more approachable situation. If you're integrating data into an MES or either to the ERP directly, you would like to set up one pipeline, for example, like saying that the work order is finished. Work order, then you expect the data point order ID as a string. You expect the order perhaps quantity, your due date, person or station, which is what's now operated on. And you expect only those four, independent if the machine is now from provider A, B, C, D, or age 10, 15, 5 years old. And now with this data model, you can now standardize the API to the MES system while making sure it only works, it will work. And secondly, now you can sort in all your machines and make sure that nothing is drifting there, and thereby reducing drastically the development time spent on the API to other systems by already making sure data is only clean there.
Yeah. So, but let me, now that we talked a lot about these already, some prerequisites and additional elements, this is a very simple data model. Yeah. So assume it's pretty much like a template which has to be filled. Okay. So for this specific data model, there are data contracts configured, which is pretty much like a function to check the template of the data model that you created. And then whenever data is coming through, pretty much checking, hey, is this according to the format? If not, give me an error message, don't take this data point, drop it, log it, and so on, to ensure that the data model is functional as much as possible. Yeah? So these are the data contracts. To the data contracts, we are then connecting stream processes, which pretty much means I'm then mapping specific tags that I found to this data contract, so which I'm going to show you now. Yeah. So as I remember, I connected the specific machine over here. I'm going to add a stream processor, which is now using a specific data contract. Let's now take this oven v2. And over here, I can browse now all the data points that I connected. Let me take this one. This is pretty much the variable name. And over here, you see this is the only data point and data model I defined. Yeah. So here I can just do the work manually. I can do also simple calculations in here, add a drift, whatever, and so on. So just like simple JavaScript operations. Yeah. So you could also multiply individual tags if you want to do that, and create exactly what you're looking for. Case statements for error messages and so on could also be a case. Yeah.
Very fast English. Luciano is complaining. Sorry.
Yeah, sorry. Gonna slow it down then, yeah. Once I've done that,
you need to enter
a name, and then can save and deploy. So, and this will pretty much, it's gonna set up the stream processor, which is checking a template, checking what data is being moved through it. The stream processor is pretty much moving the data to the data contract. The data contract is checking the template, and the data is coming in and ensuring that the data.
And what you can see now, it's also really cool. Why is the throughput so high? One of the key advantages of Kafka is that it now starts with offset 0. So it will check now your UNS, and not only from the status quo onward, which could be but also be configured. It will check now each available data tag that's now inside your topics already before creating the data contact, and now push all this data through it to be then available in the new data model. Yeah. can be configured, but this is one of the key advantages of Kafka, being able to now go back in time and move all the old events also through this data contract.
And what you see over here in the topic browser now, that the data that we collected is now under a different name. So we're standardizing the tag name and is in the exact position that we defined before behind a very specific data contract. Yeah, so you see now over here, oven v2, that's exactly where we're pushing the data to. It's fulfilling the requirements, so I can see now the data. If it wouldn't be the case, I wouldn't see any data. I would just see error logs in a specific data contract leading back to this one stream processor, which is sending us data. Yeah. So by that, you pretty much, from an enterprise central IT, OT perspective, enforcing this specific integration to be based on your standards that you want to have.
Perhaps also one interesting fact for the more tech-savvy persons in the audience. So what does it mean to check the data point against the data contract? So on the technical side, we are all using so-called schemas inside Red Panda. So this is actually a feature which is actually exactly that already implemented on the Kafka level. So we are specifying which tags, etc., keys, etc., needs to be available. And now this is a feature that we are now building on top of, and which is then also super well tested and not something that we are coming up with, which is actually like a classical problem to have if you're using data streaming applications, and we are just making this now applicable for manufacturing environments, but still super scalable and super mature.
So let's now assume we will continuously evolve our data model. Yeah, very classic situation. We're connecting a machine. We have like 10 data points. After a couple of weeks, months, people want to have additional data points. Hey, can we add this tag? Can we add additionally sensor data, this and that, and so on? And of course, in this moment, suddenly you have to evolve your data model and extend it, and maybe even exchange specific naming conventions and so on. So in that case, you would go once again to the data model and then create a new version, which means pretty much, let's assume it's a bit more complex situation that you're trying to capture here. Copy this one. There we go. So over here, you would then have alarms as a string, belt speed, energy consumption, and so on, and additional temperatures for the process, oil and so on. Yeah. So this would be a bigger data model. Once you deploy it, you would see once again the changes. So what is going to be different, and then deploy this one now. An important thing is here's now version 3. But when it comes to data contracts, I have all of the data contracts v1, v2, v3 still there and still active, which means that my integration that I did just before with the stream system v2 is still there, up and running. And it's still collecting data, it's still working.
You can still rely on it.
Exactly, which means if I now build up integration to MES, for example, to ERP, anything else, I can rely on this data contract to be still there and my integration is still working. And then you can selectively migrate to a newer data model if needed. Yeah. So this way, any new requirements, for example, from data scientists, from IT business, and so on, you can capture, you can build it up. But at the same time, you're not destroying old integrations just because you added a data point, or changed specific naming conventions and so on. So both worlds would be still working, which is super charming. Otherwise, it would be very difficult to scale because continuously the UNS will grow. It's going to be very organic. And the more people are interested in the data, the more they will work with it, the more they will adapt, add data points, and so on. And you have to be flexible, while at the same time, like having this governance idea to make the most out of it.
I think this like a contract, you cannot revoke it single-handedly. You need to be both sides of the coin. You need to flip it. There was an interesting question. To what extent can you do this as code?
Really good question. Yeah, because as before, all of the configurations that we have are pretty much also just a config file. Yeah. So here's the magic happening in the background. You see that this is in advanced mode. Be careful with that because it's pretty much exactly
obviously
the config file of the Docker. So if something goes wrong, Docker doesn't start potentially. So just be aware of that. And what you see over here is exactly what we defined, just as a long YAML file. Yeah. So you see over here I created for this specific connection actually a template. Yeah, see with the node IDs and so on, just automatically. And to actually build up this connection, then the new protocol converter is then referencing exactly this template. Yeah, so here you see then dynamic variable being set as this IP address, this port, this location, and so on. So if you work with this config file, you would only create like 1 to 2, for example, especially like Modbus templates. Yeah, typically you always have the same like 5 to 10 data points you want to read out. You have a lot of times the same Modbus devices you would have it once in the code, and then always reference it to a new protocol converter, and then just fill in these dynamic variables here, which is going to make it also leaner code-wise and easier to manage.
I think this is also like a specific design decision that we took, because I think manufacturing lives in drag and drop interface a lot of times. Yeah, you have this and you fold and you take it over. But if you start really scaling in an architecture like that, it's mostly repetitive work with a little bit of like variance in between, which is actually a perfect environment to actually first copy and paste, and then secondly also version via Git, etc. And now also enabling you to work with your IDE of choice. Yeah, so like a power user doesn't want to use a drag and drop interface. He wants to be as fast and efficient as possible. And this now enables you to use any large language model of your choice to create those files. Yeah, it's mostly repetitive work. Perhaps you have an Excel file or a CSV as an input, which now states these are my 50 machines that I have, and these are the credentials, these are the IP addresses. You can now build a script to put it into that. Or you can also easily iterate with a large language model on top of it, which we're actually doing internally a lot. And I think this is a direction where we would like to take the product even more by removing the unnecessary repetitive steps or the to some degree like this monkey work which doesn't inherently add value, but is still necessary. And yeah, this is a really, really good step in that direction.
Yeah, this also enables you to define your unified namespace of the stream processes with the team. So you could do this in an Excel format, whatever you like, and then feed this to an LLM to actually create this config file for you. Yeah. Because I think after one of our customers was trying it extensively, we extended the limits of this config file, and now over 100,000 lines are fine. Yeah. So you can really just have a very huge config file, deploy it here, and all of the configurations will be immediately implemented and be running. Yeah. And then you can just version it, redeploy to the different site, and just use the templates that you built.
So now there are two other questions. So the first one, is it possible to make data transformations in the data contract before it sends to the data or broker? Yes, but I think you would actually do it more on the bridge level.
Exactly. Yeah.
For example, transformation from Celsius to Fahrenheit was referenced. Yes, you can do that. Matthias will show it.
So this is going to happen pretty much over here.
Yeah.
So you see I'm subscribing here to 3 different node IDs. I can here, as an example, reference some of the node IDs, and if the condition is met, so the node ID is matching, please do this specific operation. And here you see that we're pretty much moving from Celsius to Kelvin. Could be also the other way around. And so on.
Yeah. Which is also like what perhaps the careful looker already saw. We added some more features to the Monaco code editor, which also on hover like gives you more information, autocompletes, etc., which will also be improving also in the future. There was a question from Jasper: could you Git control all of these config files? If so, how? Sure. Why not? So I think there are 2 ways of versioning. So the first one is a really fully integrated one via the management console. Yeah. But I think your direction more comes into how I'm able to use really Git. And fundamentally how it works, there's a container which has this specific file which he takes continuously, reads through, and then if changes are there, it will now apply those changes, for example, the new PLC, and build a bridge from that. So what you would do now is either have like a remote registry where you have now your files, you make changes to that, and then CI/CD that new file into the environment where the Docker container can read it, or you can directly use it on your laptop or in your environment of choice. So yeah, fully compatible via Git, but this is then more either in the management console where we take the responsibility, or feel free. Yeah, so you can do whatever you would like to do, as it's just code.
Yeah.
So it can also be perfectly referenced in Git files. Yeah.
Exactly. So yeah, your data infrastructure, your code. We prefer, of course, to do it over the management console just because we have some checks about the config file. So if there's any misconfiguration and so on, we can pretty much check it and give you error messages before you actually deploy it, which is going to make the whole process way more stable for you, without building up a CI/CD pipeline, doing your checks on your own, and so on and so forth.
But also like the CI/CD pipelines, in my opinion, there's so much that could go wrong. and which actually implies that there should be a more integrated solution to that. Yeah. So how do I perceive logs? How do I aggregate them? So for example, data bridge is not providing any more data, which would now in a logging system would say this is a faulty component or the UMH core is faulty. But we have also checks internally of the management console, which will now check for the connection, the underlying network connection, if it's still active. So there are a lot of things which actually make sense to use the management console for actually those checks, which are a little bit in contrast to those workflows. But I think there are two roads, both are perfectly viable. It depends a little bit about how much you would like to do on your own versus how much you would just like to use the product.
Cool.
I think from our end.
I think so too. If you have any other questions, yeah, follow us on Discord, get in there, and just message us anywhere.
What's a pleasure.